Hello everyone! In this video, I'll be introducing you to series and sigma notation, as well as how to use a graphic calculator to work with them. Let me remind you of the definition of a sequence. A sequence is a set of numbers written in a certain, and there is an example for 1, 3, 7, and so on. A series is the sum of the terms of a sequence. When we add up the terms in a sequence, we get a series, which can either be finite, with a specific number of terms, or infinite, continuing indefinitely. In our earlier example, we had the sequence 1, 3, 5, 7, and so on. If we add the terms of this sequence together, we get a series. For example, the sum of the first few terms would be 1 plus 3 plus 7 plus 9. In this example, we stopped at the fourth term. This is called the sum of the first four terms of the sequence. Sn represent the sum of the first n terms of the sequence. Let me show you an introductory example to clarify the basic idea of a series. Consider the sequence 1, 4, 9, 16, and so on. Here Sn represents the sum of the first n terms of the sequence. So, you'll calculate the sum of the first term, the sum of the first two terms, and the sum of the first three terms respectively. Sigma notation uses the Greek capital letter to represent the sum of a series. It's a compact way to express the sum of terms in a sequence. At the bottom of the sigma notation, you'll see the first number of the interval, which indicates where the series starts. At the top, you'll see the last number, which shows where the series ends. This notation helps to specify exactly which terms in the sequence are being added together. Sigma notation is used to compact the sum of numbers in a short and efficient way. For example, if Sn represents the sum of the first n terms of a sequence, instead of writing out each term one by one, we can use sigma notation. This allows us to express the sum of these terms more concisely and clearly, like in the following example. According to the definition of sigma notation, we will substitute numbers for k from 2 to 4 inclusively. This means we'll plug in each integer value from 2 to 4 into the formula inside the sigma notation and then sum the results. 5 plus 7 plus 9 equals to 21. Let's solve one more example to clarify the written method. The difference between this question and the previous one is that there are two terms, one in sigma notation and a second term which is -1. In this case, the sigma notation term is 3m, and we need to carefully consider how the -1 impacts the overall sum. According to the definition of sigma notation, we will substitute numbers for m from 1 to 3 inclusively. This means we'll plug in each integer value from 1 to 3 into the formula inside the sigma notation and then sum the results. After calculating the sum using sigma notation, we will then subtract 1 from the total sum. This adjustment accounts for the negative term in the expression. This clarification should help in understanding the impact of the negative term in the series. Answer of the question is 17. Now, I will use the graphic calculator to solve the same question. First, I will rewrite the question in terms of x because the calculator uses x as the variable. This allows us to input the expression directly into the calculator. Now it's calculator time. First, press the math button. Then, scroll down and select the summation notation. You will see the sigma notation appear on the screen. For the next step, press the X button, followed by entering the numbers 1 and 3, which will set up the limits of your summation. Then enter 3x into the sigma notation. Finally, add the second term, -1, to complete the expression. As a result, after following these steps on the calculator, we get the same answer, 17. I hope in this video you've learned the basic idea of series and sigma notation, as well as how to use a calculator to compute sums using sigma notation. Thanks for watching.